R's complement. Start with the R complement. We will actually another one for the R minus 1. So that's actually 3-step. 1, 2, 3. So let's see how we could do that. Step number 1. If you want to get the R's complement of any number, you need to keep the 0 on the right side of the number. So I'm writing here. Keep the zeros on the right side of the number. Okay, step 1. Step number 2 says subtract first non-zero digit in the right side from the number side of the number from R. So let's write it down here too. So the second step, subtract first non-zero digits in right side of the number from R. Okay, and the last one, which is step number 3, we need to subtract all other digits. All other digits of the number from R minus 1. R minus 1. I'm just underline here, which is they are important. Okay. So let's have one example. So let's go back to the book and see if we have some of them. So yeah, here in the book is actually page 12. So let's do this. So we have one number which is in base 10. Again, that is R minus 1. So I don't want to do that because I want to have one example for R's complement. Yeah, the second example in that page, it's actually the first complement again. So I'm not interested on that because I want to have one for R. And finally, 10's complement. Yeah, I found it, which is in the end of the page 12. So you have one number. Okay, you have one number. So this is example. So the question is, you have these number, which is 0, 1, 2, 3, 9, 8. The number is in base 10. Okay. So you tell me what is the R's complement should be what? Should be 10's complement of the number. Okay. 10's complement, we want to actually find it. 10's complement of these number is actually the question. Okay. So let's see how you could do that. So you just comes to the shortcut that you have. Keep the zeros on the right side. So do we have any 0 on the right side? No. So that means step 1 actually doesn't actually apply here. So number 2, subtract the first non-zero digit in the right side of the number from the R. So tell me which of these digits is in the first non-zero digit in the right side. Type on the chat box. Which one is first? What is the first non-zero digit in the right side? Definitely is 8, right? So the first non-zero from the right side is 8. So you need to subtract that from R. What is the R here is our base, which is 10. So I subtract 8 from 10, you got 2. So that means I write here 2. So what is the step 3? So step 3, it is subtract all other digits from R minus 1. R is 10, 10 minus 1 is 9. So the all others should be subtracts from 9, okay? So 9 minus 9, you have 0. So what is the 9 minus 3 is 6. What is the 9 minus 2 is 7. What is the 9 minus 1 is 8. What is the 9 minus 0 is 9. So you have 987602 is the tens complement of these number that you have here. Okay. So any other question? So let's have one more, which is again, there is another example in the end of page 12. So let's do that. So the number again is in base 10. Also, I don't like to have again from base 10, but okay, let's do that. So 2, 4, 6, 7, actually 0, 0. That is in base actually 10. Just make sure we have the right number, 2, 4, 6, 7, 0, 0, okay? So the question is the same thing. What is the tens complement of these numbers? Okay, so if you actually follow the steps that we have here and explain it. So what we need to do is first, what is the first step? Keep the zeros on the right side of the number. So do we have any zero on the right side of the number? Yes, no? You have, right? So these two zeros you have. I'm not going to touch them, so I just add these two zeros here, okay? So step number 2, subtract the first non-zero digit in the right side of the number from the R. So that means this is a first non-zero from the right side. You need to subtract from 10, which is R, right? So it should be actually 3. So then the rest, which is whatever you have here, you just need to subtract from R minus 1, which is here you are in base 10. R minus 1 is 10 minus 1, which is 9, okay? So you subtract all of them from 9. So 6, actually 9 minus 6, you have again 3. 9 minus 4, you have 5. And 9 minus 2, definitely you have 7, okay? So 7, 5, 3, 3, 0, 0 will be actually your tens complement of this number that you have. Okay, so is it clear what I'm doing here? So this is actually the other example. So let's see if I could find some from other bases, probably base 2, which is what we most use. So yeah, they like to do this too. So you have this time, again, the question is same. So you have one number, this time that is in base 2. It is 1, 1, 0, 1, 1, 0, 0. Okay, just make sure we have the right thing. 1, 1, 0, 1, 1, 0, 0. Okay, that is in base 2. So you tell me the R's complement should be what? Should be the 2, twos. Maybe that's better. Not, this is wrong. You should say tens or twos complement. So the complement is same. What is the number? So the same thing, okay? So the same story. So you start with here, we say, okay, keep the zeros on the right, step on number one. So this one is the first number on the non-zero from the right side. You subtract from 2, which is the r. Subtract from r. R here is 2. 2 minus 1 is 1, okay? And the rest you need to subtract from r minus 1, which is 2 minus 1, which is 1. So that means 1 minus 1. So see all of these, the rest should be subtract from 1. So 1 minus 1 is 0. Again, 0 minus 1 or 1 minus 0 is 1. 1 minus 1 is 0 and 0. So that will be actually the 2 complement of these numbers. Okay? Again, the same. Just you have the steps here, should be easy, right? Just follow them. It doesn't matter which base, we have the same steps that we need to follow. Whenever I just change the base, the only thing is changed is r and r minus 1, right? So the all is should be the same. So one more example for base 2. So this is actually the second example. You actually put 0, 1, 1, 0, 1, 1, 1. Again, that is in base 2. So the question is, what is that number in, actually 2 complement of this number is what? So number is 0, 1, 1, 0, 1, 1, 1, okay? It's the same story, right? Just the same 3 steps. So is there any 0 on the right side? No, you don't have any 0. So that means you start with this first non-zero is this. You subtract that from r, which is 2. 2 minus 1, you have 1. So this is 1, okay? And all others, which is these numbers or digits that you see, you subtract from the 1. So whenever you subtract from 1, so if it is 1 will be 0, if that 0 will be 1, right? Because you are in base 2. So let's do that. The first one should be minus 1, so it should be 2, 0. Again, you have 1, then you have 2, 0. Again, you have 1, okay? So if I check the chat box and see you actually give a right answer, yeah, 1, 2, 0, 1, yeah, that definitely whatever you type on the chat box is right, okay? So this is actually the other example, okay? So usually you could actually somehow you could have the other version of this shortcut and these 3 steps for base 2, okay? Also these works for all other bases, even R, I don't know, 5, 10, 12, whatever you have. But you could somehow make other version of this just for base 2. For base 2, we could say, okay, whenever you want to find the 2 complement of the number, which is in base 2, so you just keep the first non-zero from the right side. See, I keep for this one, I keep the first non-zero from the right side, and the rest just change 0 to 1, 1 to 0. So I keep just these two 0 and 1, then the rest is 0 to 1 to 0. So see these 1 actually change to 0. So sorry, I should show here. So I keep this actually the first non-zero from the right, keep that. So see, I keep this 1. So then the rest, 1 is 0. So that means it should be 0, which is you have 0 here, this one. So then you have another, this 0 should be 1, which is changed to 1, and these two 1 changed to the 0. So which is exactly the same thing that you have here, but it's in more simple way. You could remember that for base 2. So see, it's actually should be the same way for the second one. So I keep the first non-zero from the right side, which is this one. So see, first non-zero from the right side, okay? And the rest change 1 to 0, 0 to 1. So here you have 2, 1, change to 0. This is 0, you change this to the 1. So this is 1, 1, which is actually 2, 0. And this is 0, and this should be changed to 1, okay? So this is somehow other version of these 3 steps that you could remember, which is just works for base actually 2. So I just repeat that again. So you could just keep the first non-zero from the right side, no change on that, and the rest 1 to 0 and 0 to 1. Okay. So you could actually remember that too. So let's actually finish this with one more example that we have in. So you have 1, 3, 5 that is in base 10, right? So the question is, what is the tens complement of that? So tens complement. Okay. So as usual, we just follow that 3 steps. So the first, is there any non-zero on the right? No. So the first non-zero from the right, subtract from the R is 10. So you have 5 minus 10, you have 5. Okay. So the rest should be subtract from the 9. So 9 minus 3, you have 6, and also 9 minus 1 is 8. Yeah, that's right. So 8, 6, 5 will be actually these tens complement of these numbers.